Like humans, galaxies can't stand to be alone. Nudged by gravity, galaxies tend to group together, and some even end up in the universe's equivalent of bustling megacities, clusters of up to 1,000 galaxies, collectively outweighing our Sun 1,000,000 billion times over. But for all the stars glimmering in these clusters, only a fraction of the entire structure's mass is visible. As far as scientists can tell, a cluster's real heft lies within a material that can't be seen, an invisible, mysterious substance called dark matter. Like the concrete and asphalt beneath a city, a vast spherical halo of dark matter undergirds the whole cluster of galaxies. And just as buildings rise from the city streets, each individual galaxy is embedded within its own subhalo of dark matter. For decades, astronomers have tried to understand how dark matter acts as the cosmos urban planner, shaping the structure of our universe. But the latest looks suggest that whatever dark matter is, it's not behaving as researchers expected. In a study published today in the journal Science, researchers examine how 11 gigantic clusters of galaxies bend the light passing through them, as seen from Earth. The study finds that these clusters harbor more than 10 times as many dense pockets of dark matter than predicted by supercomputer models. When you find such a gap, most often it reveals that there's an element of the model that needs to be refined, says study author Priyam Vardhanatarajan, a theoretical astrophysicist at Yale University. But occasionally, very rarely in the history of science, the gap actually shows you the way to a new theory. The study is the latest to poke and prod at the leading model of the universe's key ingredients and how they interact over time, known as Lambda cold dark matter. According to this model, no more than 5% of the universe's combined matter and energy is baryonic matter, the familiar mix of particles that makes up planets, stars, galaxies, organisms, and everything else we can see. The bulk of the universe, 68% or so, is made of dark energy, represented by the Greek letter lambda, lambda an enigmatic repulsive force that drives the accelerating expansion of the universe. The remaining 27% of the universe is made of an invisible substance called dark matter. Per the model, dark matter has mass and can create gravitational fields, but it doesn't react with itself, emit light, or readily interact with normal matter other than through gravity. To put Lambda seed to the test, researchers led by Massimo Meneghetti, an astronomer at the Astronomical Observatory of Bologna in Italy, decided to look at some of the biggest known galaxy clusters. The team wanted to examine how mass is distributed within a cluster by measuring a phenomenon that appears in telescopes like a trippy camera effect.